Today we're going to learn about function notation. So function notation is just a fancy way of writing y. So fill in that blank right on your notes for me. So normally if you think of an equation of a line, you think y equals mx plus b. We are just replacing this y with this notation right here. And that notation is said right here in your next blank, f of x. Another way of saying that is a function of x. So we know it's a function, we know it's going to pass the vertical line test before we even graph it. So x is the input, so whatever is in this blank right here, that is what you are going to plug in. So plug in to the expression that will be given to you. And then y is going to be the output. So after you finish solving this, whatever f of x is equal to will be your output. So let's fill that out right here. So whatever f of x is equal to after we use PEMDAS to evaluate it. Promise that's going to make a lot more sense in just a second. So let's go and solve a problem. I'm going to give you a few more seconds to write that if you need to. If you need to, pause the video and give everyone enough time to write that down. So here's our old-fashioned function machine, and we always have an input that goes in this section, goes through here, a roll happens, and we get an output out here. Well, the way this is read is find f of -5 if f of x equals 4 parentheses x plus 3 squared. So the 4 parentheses x plus 3 squared is now our rule. It used to be something like times 5 or add 2. Now we've got a big expression there. So I know it's a function because it says f of x, and look at what they replaced inside my x. They replaced that x is -5. So I need to plug in -5 to this function. So I'm going to put it in place right here in this x right here, and then I'm going to do all this math and get an output out here. So let's go over here to the side and do that work. So we've got 4 parentheses. We're going to plug in that -5 that we said. We're going to add 3. We're going to square everything, and then we're going to multiply by 4 later. So I've got, PEMDAS says parentheses first, -5 plus 3 is -2. Make sure you keep those parentheses on that because we want to say -2 times -2, which is +4. And then I need to bring down this times 4 that's been out there the entire time and get our final answer, 16. So that was our output. So I know f of x, f of -5 is equal to 16. So when I plug -5 into this function, I will get 16 out. See how that works? If you think you've got it, pause the video and try a couple of these. If we still are feeling a little iffy, let's do a couple more together. So if I want to say f of 0, all I want to do is plug in 0 for wherever I see x in this function up here. So I see 3 times x, which is now going to be the 0, minus 2. So I'm going to use PEMDAS. I'm going to do multiplication first. So 3 times 0 is 0, minus 2 is -2. So the proper way of writing this is the value of the function when x equals 0. That's how we can say that really quickly. F of 0 equals -2. Let's go over here to f of 2. We've got 3 times my x again. Again, I'm going right here. That's where I'm getting all this information from. And my value of x this time is 2 minus 2. So multiplication first. It's more important. Subtract my 2 next. So the value of this function when x is 2 is 4. We've got 2 more to do. Try them a little ahead of me. If you need me to do all the work, just wait a second. You can get it right off the board. So we're going to plug in 1. So I'm going to say that my value of x this time is 1. Then we're going to subtract 2. So 3 times 1 is 3, minus 2 is 1. So the value of the function when f is 1 is 1. Let's try another one over here. Plugging in -2, so I'm going to say 3 times -2 minus 2. 3 times -2 is -6, minus another 2. Watch your negatives. That actually makes a bigger negative, -8. So the value of the function when x is negative 2 is negative 8. On the back side of these notes, we've brought back an old friend. Those are absolute value bars. So remember, they are telling us the distance from 0. So whatever value we get in there, it actually turns positive before we get out of those bars. So that's absolute value. So again, I said, what is f of 0? So I'm going to plug it in. So I've got the absolute value of what used to be x is now going to be 0 minus 1. So I've got the absolute value. I just need to do that subtraction real quick. So 0 minus 1 is negative 1. And the absolute value of negative 1 is 1. So the value of the function when x equals 0 is 1. For a negative 8, I plug that in. So again, look at what's happened. I've taken this x up here and I'm plugging in whatever value of x they tell me, and I'm going to solve it with PEMDAS. So negative 8 minus 1 is negative 9. The absolute value of that is positive 9. So the value of this function when x is negative 8 is 9. Again, pause it, see if you can do the other two before me. If you can't, just stick right here and listen to the rest. So it says f of 6. So I'm going to plug in x equals 6 now. So I've got 6 minus 1 in these absolute values. So make sure you make those really nice and big so they don't look like your ones. And that is 5, but the absolute value of 5 is still 5. It is 5 away from 0. So the value of the function when x equals 6 is 5. Alright, one last one over here. We've got the value of the function now when x equals negative 6. So the absolute value of negative 6 minus 1 is the absolute value of negative 7, which is just 7. So the value of the function when x is negative 6 is 7. Alright. For this next example, I told you the domain of this function. These are actually the same type of problem. The ones we were doing up here and the ones we were doing down here. I'm just phrasing it a different way. And I've told you 4 values at once of the domain. Now if you think back to our last quiz, your domain are your x values. So that's our important piece of information. I could also say use this domain to find the range. And if I'm talking about the range, I'm just talking about this g of x, which is the same as our y. This did switch names. Usually we call it f of x and suddenly it's g of x. They just do that to tell different functions apart. So maybe we already used f of x once and now we want to talk about g of x. Maybe we use g of x next and we want to talk about h of x. So we could call these functions any letter, parentheses, that x inside. So what I suggest to do when you have 4 values at once here is to make a table, so a t-chart. So I gave you domain values. I want the range values. And we're going to actually make this a little bit bigger so we can show the work right in it. So we're going to show our y values over here. So if I want the domain of 0, 1, 2, 3. And in order to get the range values out, I need to plug it in. So I've got negative 2 times 0 plus 1. We'll solve it in a bit. Let's finish plugging in. We've got negative 2 times 1 now plus 1. Notice what's changing each time? The x. Negative 2 times 2 plus 1. We've got negative 2 times 3 plus 1. So let's go solve all these real quick. So my range values, my y values here, my outputs. Let's see what we get. Negative 2 times 0 is 0 plus 1, which is just 1. Doing a little mental math here. Negative 2 times 1 is negative 2 plus another 1. So it's negative 2 plus 1, which is still negative 1. Then we get negative 4 there, plus 1, which is the same as negative 3. And then we've got negative 6 plus 1, which is the same as negative 5. Notice a pattern. Each time it's going down by 2, but we started at 1. Alright, so I'm going to say that my final answer here is that my range, my y values, are, let's do them least to greatest, negative 5, negative 3, negative 1, and 1. So that would be the way I expect them to phrase that on the SOL. Here's your domain, what's your range? And that would be the answer you're looking for. Let's try it again. If you want to try this one on your own, pause the video and then come back and check your answer later. If you need to stay here with me. So we've got a new domain for a new function, and our new domain is 1, -3, -4.5, and 6. So again, I saw the word domain, thought x values, then I saw the set of x values they gave me, made a table just to keep it all nice and organized, and now I'm just going to plug in those x values right here into this function right here. So 1.5 plus, says x squared, so I'm going to say 1 squared. Then I'm going to say 1.5 plus -3 squared. Then I'm going to say 1.5 plus -4.5 squared. And then I'm going to say 1.5 plus 6 squared. Now, I didn't mention it as I was doing it, but maybe you noticed it, that sometimes I used parentheses and sometimes I didn't use parentheses. And the difference was I plugging in a negative number where I needed to keep that negative inside the squared, or just a positive number that wouldn't matter if it was in parentheses or not. So again, these parentheses keep that negative in the square, so when I square it, it will become positive. So I'm going to go and do the work now. So PEMDAS says exponents are most important, so this is really 1.5 plus 1 squared, that's 1 times 1, that's still 1. So the final answer there is 2.5. My next one, -3 times -3 is positive 9. So I've got 1.5 plus positive 9, which is 10.5. So this next one, you might need to get out your calculator. We've got -4.5 times -4.5, which is 20.25. And then we need to add 1.5 to that. So we're at 21.75. Next one, we've got 6 squared, which is 6 and 6, which is 36, plus 1.5, which is 37.5. So our final answer, what we are going to write, you could say y equals, you could say the range. I'm going to say y equals for this one. We've got all these values, let's do them least to greatest. So we've got 2.5, we've got 10.5, we've got 21.75, and we've got 37.5. That was nice that they were in order for us. We didn't have to think too hard on that one. All right, thank you. Now it's time to go practice.